Hello, Ferdinand here again. Welcome to the second part of the Cinema 4D C++ SDK for Windows Getting Started series. In this part, we're going to build a build system and have a bit closer look at the content of build systems. In the last part, we configured both an MSVC, so this build system, and a Clang build system. In this part, we will be exclusively using the MSVC build system. So let's start with having a look at the build systems which we generated in the last part. When we open a build system folder, this might look a little bit confusing, but it's actually not that hard to understand. So the first thing which we can point out here is this C4D -SDK.sln, so the Visual Studio Solution file. This is the file which will be opened when you click here on Open Project. And then we see the frameworks and plugins folder reflected here. And with the plugins folder applies here the same thing which we already talked about when we talked about the filter in Visual Studio. So this folder will be called plugins even when this folder is not called plugins. So you could also, for example, call it bfoo, or you could ingest your modules scattered over your whole system. This will then all still be put into a folder called plugins here. And the general idea or structure is here that all your source code, so all the files which you added, remain here in this top level. And in the build system, they are just the configurations files. So if we go, for example, here into example assets, we see here all the build system configuration files which have been generated by CMake. And in the, so here this plugins example asset, in the plugins example asset, on the top level or the user level, there's then the actual project configuration, the resources and the source code, and possibly other stuff you put there. And the same applies for the frameworks. So in these frameworks, they actually just contain the configuration for each framework, and the frameworks folder at the top level is the actual API, which then contains here the actual source code and the actual project configuration for this framework. Yeah, and that's pretty much already it. This folder will change when we now build, so then new files will appear, and we will look at this again. And yeah, the CMake folder is exactly the same in green, so there's absolutely no difference. Okay, so let's now first close this and let's open our project in Visual Studio. So when we want to build our project, we have to make one decision first, namely if we want to build it in debug or release mode, because these are the two configurations with which we ship the SDK. When you want to debug your project, as we will do in the next video, you usually should use a debug configuration, because then debug information will be compiled into your binaries, and the debug databases, so the PDB file will be generated, and will then have much more information when debugging your plugins. But when you want to ship this to a customer, you should definitely not ship debug versions to a customer, because release binaries are much faster than debug binaries. So basically, when you're done with developing your plugin, you should always switch this to release when compiling. Yeah, that's pretty much it. What to do here, since everything else is already set up for us, so we can either just here click on this play button, or if you want to a bit more formal, you can click here this build solution, or just press F6. And while this is building, we can look at a few things. So First of all, we see here the source processor mentioned in this output, and the source processor is meta programming tool which is shipped with our frameworks, and this basically generates source code based on the source code which you write, so that actually your modules and projects work or interact correctly with our API. And you will see this source processor output often in your outputs, and we will also see in a second where this actually lands and what this means. What we can also see is here that, for example, it started, I think this means it started compiling the core framework, so this framework, and you can also see that it wants to compile this into a lib, so into a static library, which hints at the general architecture of the SDK. So the frameworks are compiled each into static libraries, and the plugins are called into modules. The modules are called compiled into dynamically linked libraries, which under Windows using the extension XDL64, which our libraries are a little bit different, and therefore we don't use the extension DLL. And these dynamic libraries are then loaded by Cinema 4D on startup and linked internally against Cinema 4D, and so that they can correctly communicate with Cinema 4D. Each of these modules statically links against the framework which is required. So the compilation is now done, I think, hopefully, yeah. So you shouldn't have here any errors. And when you recompile, then of course you might see something like up to date, but you shouldn't have any failed, and this one skipped is okay. So let's go back to VS Code and have a look at our build system again. Now this bin folder appeared here, and this bin folder has currently one subfolder, namely a debug folder, and in this debug folder this is an ellipse and a plugins folder. And this is because we compiled here with a debug configuration. If you would compile here with the release configuration, you would here have here also a release folder. And in this libs folder are exactly the framework static libraries about which we talked just a second ago. So here are all the frameworks compiled into static libraries. And in the plugins folder, to which again this pattern applies, that the thing will be called plugins no matter how this thing is named or how you generally ingest your modules, contains then the actual build output, or the build output about which you at least actually care, namely the compiled plugin binaries, which in fact are modules, because that's how Cinema calls them. So this is here a module dynamic library, and this can then be loaded by Cinema 4D. What we also see is here that here is the res folder or resource folder, and I think, does it show you? Yeah, okay, it shows you the thing is actually a dynamic link. This is as indicated here by this arrow. And this example asset res folder points to the example assets res folder, which is to be seen here. So again, the actual content is kept at the top level, and the build system just contains the generated files, and these res folders contain these, so we can look into the res folder for the example assets. They contain things like dialog, GUI definitions, string definitions, and symbol files. And if we look, for example, in example main, which has a much more complex res folders, can then also contain things like descriptions and node definitions. So they are the resources of this module, and a module expects this resource folder to lie next to its module binary. So we have to put here a symbolic link. And if you wanted to ship this build output to your customer, you basically would just have to grab this plugin binary here and the resource folder, which is here, and then zip this, and then you could ship this to a customer. This is here just the debug database. You don't need this. You, of course, shouldn't ship a debug version as we established before, so you should do this with a release version. Yeah, that is pretty much all there is to building the SDK. This is relatively straightforward. What we can still talk about is this generated folder. So this contains the output of the source processor we talked about. Generally, you can ignore this, but you should know that it exists. So if we, for example, look here into the example assets, so this is again, it just lists out all the projects which are in the build system here. And when we look in the example assets folder, we see the output of the source processor, and the major payload of that it is here in these HXX folders. And we can see here a lot of C++ files have been defined here for this asset API example, and these files are generated at build time and required so that your project actually builds. And they play lesser roles. So this example.assets is a project which is using something called the Maxon API. In the beginning, you will mostly using something called the Cinema API. So example.main is mostly about the Cinema API. And there these source processor files play a lesser role. But what can happen is that when you make a mistake in your source code, so this does not properly compile, is that you then see in your build output these HXX files popping up, and then you know where this comes from. This does not mean that there's an error in these HXX files, because they are quote-unquote always correct, because they are automatically generated, but what that usually means is that you made a mistake somewhere, and therefore the assumptions of the source processor do not hold true anymore. Okay, this concludes it about building the Cinema 4D C++ SDK. In the next part, we will have a look at debugging our project a little bit. I hope I will see you there. Happy coding and happy rendering. Bye bye.